In this video lecture, we will talk about inverse function of sine x, which is denoted by arcsin x. A function has an inverse function, then the function needs to be a one-to-one function first. Let's recall what's the meaning for the one-to-one function. You see down here on the left-hand side, we have a different x value, x1, x2 corresponds to the same value, y1, then this function will not be one-to-one. And for this one, x1, x2, x3, they are different. And then they correspond to the different elements in y. So this function will be one-to-one. Yeah, if you click on that, it will tell you this is a one-to-one function. If you click on that, it will tell you the first one on the left is not a one-to-one. Graphically, is easy to see. Algebraically, you see if y1 here in red are the same, and you have a different value for x, x1, x2. You see x1, y1, x1, y1, x2, y1, x2, y1. If you see they have the same value y, but different value x, then algebraically you can tell this is not one-to-one. But graphically it's easy to see. Some of you may worried about how about if here is one element goes to two elements in y, like this case, x2 goes to corresponds to elements in set y. Because in this case, for element in x, x2, there is no unique element in y, because there are two elements in y corresponds to element in x. So this is not even a function yet. So you want to forget about this case. Because in this case, even x1, x2, they are different, but the element in y is unique, corresponding to the original set elements in x. Okay? So we know now this is one-to-one. If you go back to look at sine x, let me get sine x picture out. And this is the graph for sine x. You know, sine pi over 6 is 1/2 right here. And also sine 5 pi over 6 is 1/2. So when you connect those two points, because y coordinates are the same, the line will be horizontal. This horizontal line meets at least, in this case, you see there at more than one element, more than one intersection with sine x. Okay? And down here on this picture is pi over 6 corresponds to 1/2. See, pi over 6 corresponds to 1/2. 5 pi over 6 corresponding to 1/2. 5 pi over 6 corresponding to 1/2. So basically the function sine is not a one-to-one. You can also see algebraically pi over 6, 1/2. That's what I wrote here. 5 pi over 6, 1/2. That's what I wrote here. So this tells us sine x originally is not a one-to-one. Okay? Yeah. And then how about if we restrict our domain from negative pi over 2 to the positive pi over 2? You see this black part. Then if you draw any horizontal line, it has at most one intersection with part of this picture. Then if the domain is restricted from negative pi over 2 to the positive pi over 2, the function will be 1 to 1. So now let's remove this general sign and get the restricted sin x. And in this restricted part, y still is from negative 1 to positive 1. Okay, and the function is increasing. All right. On this graph, you need to remove this dashed line. Let me remove that by clicking here. So this dashed line 5 pi over 6 is removed. You see here? Removed. Now the function is 1 to 1. Okay. And then in this case, when you are given 1/2, corresponding original one will no longer be 5 pi over 6. It only has pi over 6 corresponding to that. Okay, so in this case, then we know any elements here, we can find a unique one in X. We know any elements right here, then we can go back, okay, to find out the original element. So it's written in this way, Sine inverse 1/2 is pi over 6. And sine pi over 6 is 1/2. Okay? So really, when you write sine inverse, a value here equals what? It depends on how well you remember the original one. If you know original one is sine pi over 6 is 1/2, then here you can immediately write sine inverse 1/2 is pi over 6. Okay? So inverse function is nothing else but just goes from element in y, a trigonometric value, go back to find out the angle. But this angle, again, needs to be from negative pi over 2 to the positive pi over 2. Okay? So down here, basically, you get is a value, go back to the angle. The value is negative pi, is negative 1 to 1. So basically, it needs any value here has to be from negative 1 to positive 1. And angle is going to be from negative pi over 2 to the positive pi over 2. So let's get our inverse graph out. You see, this red one will be the case. We talked about this point a lot, pi over 6 1/2. That's basically the point right here. Okay? Yeah. Then how about this point? Okay, how we are going to write this one? Click here. Click here. You see, we have a sine inverse radical 3 over 2 is pi over 3. So basically, radical 3 over 2 corresponds to 2 pi over 6. Because 2 pi over 6 is reduced to pi over 3. Those two set the same thing. Okay. Similarly, you can see the originally is because sine 2 pi over 6 is radical 3 over 2. Okay. I wrote 2 pi over 6 is because that's 2/3 of the pi over 2. You use 2/3 times pi over 2, you get 2 pi over 6 or pi over 3. So we know those 2 points. Those 2 points is basically you switched x, y. Originally, you have a x 2 pi over 6, and y is radical 3 over 2. Now you go back is radical 3 over 2 and 2 pi over 6. Okay, that's why those 2 points are symmetric. Symmetric with respect to what? To this dotted line. Okay, this dotted line. Y equals x. Okay, so if you switch x and y, then another point will be right here. Function will be symmetric with the dotted line here. Y equals x. Again, since we switched, then the domain and the range will be switched. Originally, it's from -1. Originally, from negative pi over 2 to the positive pi over 2, it was the domain, now is the range. Originally, it was the range, -1 to +1. You see the highest is 1, lowest is -1 in this band. Now it switched. Okay, switched the red one from -1 to +1. -1 to +1 is the trigonometric function values now. And back here, y-axis will be the value angles. Okay, so inverse function is basically like a vehicle which sends to the trigonometric function values back to the angle. Okay, it's like a bus. When you go choose sine, it goes from left to the right. When you choose inverse, you have a bus also goes back to the x from y. Okay, so inverse function is nothing else but just go back to find out the angle. So it is not strange for us to write arcsin, because arcsin is another way to write sine inverse. Okay, so arcsin -1 is negative pi over 2. Again, is the point right here. Okay, -1 corresponding to negative pi over 2. This red one right here is because, again, it depends on if you really remember. Here you have a sine negative pi over 2. Right here is -1. Okay, so for the inverse function, when you choose the inverse, it really depends on how good you remember the original one. If you remember cosine, if you remember sine negative pi over 2 is -1, then it will be easy for you to write arcsin -1 is negative pi over 2. Okay. Now, here is something more. You see, if you don't look at the red, here is basically what we write down here. This is the one. So you choose sine on this one, choose sine on this one, choose sine on this one. Then you get is what? It's like the element first in radical 3 over 2 go back to the angle, which is pi over 3. And then it goes back again, choose sine, then you got the angle back to the value. So basically what you get is sine, sine inverse, they may cancel each other. So then you get radical 3 over 2 is actually the original value. And this is true in general right here. Okay, sine, sine inverse x is just x. Okay, yeah, so that's important thing. You also remember Sine inverse is denoted by arcsin. Okay, so this is also true. Yeah, next time I'm going to give you more examples. I'll see you later.